So your test tomorrow is on sections 2.5, 2.6, and 2.7. 2.6 and 2.7 are like together. The stuff from 2.5 will be like questions 1 and 2. You'll have one where you have to do the zeros, or given the zeros, you have to multiply the polynomial. And then you'll have one that's either irreducible over the rationals or the reals. Guys, different versions are going to have different instructions. So you have to understand the difference of over the rationals or over the reals. I'm going to set this first one up.
Well, what's over the rationals?
We're going to go over one. I'm going to set this one up. I'm not going to multiply the whole thing out on the video, but I will work it all out and post it this afternoon. But if you are given a question that says, here are the zeros, find the polynomial. If I am given x equals -1 plus 3i, what else am I given? X equals -1 minus 3i. If I am given x equals the square root of 2, what else am I given? Negative square root of 2. And you also have x equals 4. Understand that. If you are given a radical, an irrational root, you also have to account for the negative of it. Because the only way that you would get that is if you had x squared minus a number that's not a perfect square. Also, if you are given a complex, you have to account for the conjugate of that number. So to work backwards, you guys would set this up into parentheses. When I bring this over, it would be plus 1 minus 3i, x plus 1 minus 3i, or sorry, plus 3i, x minus radical 2, x plus radical 2, and then your poor old x minus 4. So combine the i's together. Combine the radicals together, and then you just have a big polynomial that you have to do. But understand, some of you got points taken off. Your answer has to be written one of two ways. F of x equals whatever your polynomial is, or your whole long polynomial set equal to 0. One or the other, but you have to have. Don't forget that. Again, I will post all of the answers, but you have to either have your polynomial f of x equals or the whole thing set equal to 0. Gene?
So, you have to have two versions of square root of 2 and 3.
Yes. All right, so if you have, yes?
Do you want us to keep on going after or just leave it at like how you had it?
Oh, no, you have to multiply the whole thing out. Okay. I'm just, for the sake of time, I'm going to post all the answers all worked out, but for the sake of time, I'm going to make sure I hit everything. All right, guys, if you notice in a question like this, tomorrow, it's not going to ask you for all three, but over the rationals versus over the reals versus find all the zeros. You have to read the directions and understand what they mean. So let's look at number 4. If I am going to solve this, what's the first thing we look for? Take out the GCF, the x. So if I take out my x, I'm left with 2x to the 4th. Actually, what else can we take out? 2x, yeah. Make it smaller. 2x. Then I'm left with x to the 4th. Minus 5x squared minus 14 equals 0, correct? Okay, so now I have a trinomial. So I have 2x. This trinomial breaks down into x squared. What times what is a negative 14 when I multiply? Yeah, negative 7, positive what? 2. Okay, I want you guys to stop right here and look at this. This is a real rational solution, correct? This is a real irrational solution. This is what kind of a solution? Imaginary. There are 3 different types. If it says to factor over the reals versus over the rationals, guys, this is where you have to understand the difference. If you were to go over the reals, what did I say first here? So I don't... Okay. If you're going to go over the rationals, rationals means pretty, remember? So I would leave this as 2x times x squared minus 7, x squared plus 2. That is over the what? Rationals. Because I can still break down x squared minus 7 and get a real number. It's just yucky. So over the rationals means pretty. Over the reals means break down anything that would give you a real answer. So that would look like this. 2x times x minus root 7, x plus root 7. That's a real answer, but it's not pretty. Remember, rational means pretty. To find all the zeros, then what do I do to all of those pieces? You set them equal to 0. So here I get x equals 0. I have x equals plus minus square root of 7. And I have x equals plus minus I root 2. Yeah?
Do we need to set any of them to 0?
You set them equal to 0 here.
No, I mean like for your answer.
No. But understand what the difference is. We talked about this on the review. Over the rationals versus over the reals. Over the rationals means only if it's going to give me a pretty answer. Over the reals means only if it's going to give me a real answer, whether it's pretty or not. Understand the differences there. Okay. And again, I'm going to post all the answers, I promise. The zeros.
And then B is irrational?
It's over the
No.
reals.
Oh.
Rational means pretty. All right, now I'm going to post all the answers, I promise. The biggest thing I can say to you guys is know the cheat sheet. Don't write it down anywhere. I'll be looking for it. But you need to understand, if you're talking about domain and vertical asymptotes, where do we look? Denominator. If you're talking about the zeros or the X-intercepts, where do you look?
Numerator.
The numerator, good. How do you find the slant asymptote? Yes, I'll send it the first time, I forgot. Okay, we're back. So if you have a question, you're going to have questions that just say, tell me the domain and the vertical asymptotes. That's when you're like, oh, okay, domain, I have to write it in interval notation, right? Interval notation. Vertical, notate, T-A-T-I-O-N. Vertical asymptotes and domain go with the denominator. And when I write my vertical asymptote, it's going to be what letter? X equals. You have to have that. Okay, your horizontal asymptote. I'm going to do one whole example. I just want to go through this. Your horizontal asymptote is y equals. Good. That's where we compare the numerator degree to the denominator degree. You're comparing the numerator to the denominator. Your x-intercepts, you're going to set the numerator equal to 0, and you write it as a what? Ordered pair, x comma 0. Good. That is very important that you guys follow all those instructions. So if you have a question that says find the slant asymptote, what do? Long division. Long division for slant asymptote. How does your answer need to be written if you have a slant asymptote? Y equals mx plus b. If you forget the y equals, guys, I'm taking points off. Please be aware of that. Your slant asymptote, when you do the long division, Gene, it's got to say y equals, then whatever you get. Everybody with me?
Yeah.
Okay. Let's do a problem. Let's do one of these. You guys are going to have one of these graphing ones.
Only one of them?
Just one where you have to graph it. Yeah.
Questions are
I think there's like numbered 8 or 9, but there's lots of
Like
pieces.
80.
Yeah. All right, so if you're going to find all of the stuff, and I will have on this question, I'll have line for domain, line for this, line for that. If anything doesn't exist, if it doesn't have a slant asymptote, what do you write?
None.
None. If it doesn't have an x-intercept, what do you write? None. Okay, make sure that you say something. But if you're going to go through the list, let's find the domain and also the vertical asymptotes at the same time, because those two things go together. So your domain, where do I look? What do I do? Denominator not equal to 0. Good. So when I solve this, I get x squared cannot be plus minus, whoops, just kidding. I don't want to skip too many steps. So 16, right? Take the square root. So x cannot be plus minus 4. Very simple math, but you guys understand where you need to look. So your vertical asymptotes are going to be at x equals -4 and x equals +4. If you want to write plus minus, that's fine. Just don't forget you have 2 of them. Your domain needs to go from -infinity to +infinity and tell me all of the numbers that you can and can't use.
-3 to -4.
-infinity to -4.
And then
U,
-4
Negative 4 to 4. U. Perfect. Good job, guys. Very good. Very good. Now, if we're going to next talk about our horizontal asymptotes, we compare the degrees of the numerator and the denominator. What is the degree of the numerator? What's the degree of the denominator? It's the highest exponent. 2 and 2. 2 and 2. What is the comparison there? 2 what 2? Equals. So I know my horizontal asymptote is that y equals, what is the leading coefficient of the numerator? 2. What's the leading coefficient of the denominator? 1. So your horizontal asymptote is at y equals 2. Everybody with?
Yes.
Does this have a slant asymptote? No. Okay? That's why I asked that. You're like, well, how did you know that? A couple reasons. If you have a horizontal asymptote, are you going to have a slant one? No. Another thing you can look at is compare the degrees of the numerator. Guys, if you were going to divide x squared into x squared, how many times does x squared go into x squared? Once. It doesn't go in x amount of times. It doesn't go in 7x. It goes in 1. So make sure, if you are going to try and do the long division, the numerator degree has to be less than the denominator degree if you are going to have a slant asymptote. Yes, ma'am?
So I can only get the horizontal asymptote, and if I do it, then I don't get the slant one, and just the same as well for the switch.
So, yeah.
Will you ever not have either?
No. So if we're going to go to slant asymptote, you guys are going to tell me how much. You're going to say none. Somebody first period is like, can I just like go like this and then point? Okay, fine. If that makes you feel better, that's fine. If you want to actually do the division, x squared minus 16 into 2x squared. Hang on, Gene.
So there's a
Hang on, Gene. Hang on. So x squared into 2x squared. It wouldn't be 2. What would I have to do? Well, yeah. Okay, yeah. Because I was going to talk about expanding it, but never mind. So this, look, y equals mx plus b, right? This says y equals 2, which is what your horizontal asymptote is. Your slant asymptote, that's why it doesn't exist. So if we're going to talk about X-Intercepts, that's my zeros, right? I'm not sure what I named it on the test, so you just know both those things. How do you find the X-Intercepts? What do we do? You set the numerator equal to 0. So 2x squared equals 0. Divide by 2. X squared equals 0. Take the square root. What's x equal?
0.
How do I write my X-intercept? 0, comma 0. Good. How do we find Y-intercepts? Plug everything in your equation. Zeros for x's. So if I put a 0 here and a 0 here, I get 0 over negative 16. What is that answer? 0. That is an intercept, hold on, at 0, 0. If you had 16 over 0, what would it be? None. Good. Make sure you see the difference there.
On the test, if both of the intercepts are the same, is it fine like 1 point? Or did you want us to show it?
No, you need to write because there's going to be a different line for x and for y. So don't just leave it blank because then I think you don't know.
On the graph, it's fine.
Yeah. Mm-hmm. Yeah. What's up, Marcel?
How do you find the X-intercept again?
Set the numerator equal to 0.
Okay.
Why is that 0, 0? Or not?
If you had 0 over negative 16, which is what we got, that equals 0. If you had negative 16 over 0, that would be none. One has an intercept, one doesn't. And how do you find the holes, guys? You do what?
You factor.
Okay, factor numerator, denominator.
And see if any of them
See if anything cancels out. So 2x squared, can't factor anything. This becomes x minus 4x plus 4. Do you have anything that is exactly the same?
No.
Nope. So your answer for holes is none. No holes, whatever.
If there was X minus 1 on the top and on the bottom.
So you'd say hole at, you could either say x minus 1 or you could say hole at x equals positive 1.
Okay.
So
No. Did you say 1, Marcelo?
4.
Oh, I'm sorry. I thought I heard. Yeah. But yeah, the number.
Okay. So something has to be the same.
Exactly the same. Yep.
This is not us. When we get the whole, we you have to plug in the hole back into the thing for the Y part of the hole, right? Like, if it's, you right?
Don't worry about it. Sure. All right, so guys, when you look, you just ran through all of those things with absolutely no problem. Right? Where you guys are getting stuck is, I don't know where to put the graph. All you do to figure out where to put the graph is plug in points. But the major things, the major things on the graph are your asymptotes and your intercepts. You've got to get those on the graph first. So where are your vertical asymptotes? At -4, -4 and +4. X equals or Y equals? X equals. So I'm going to go over here to 1, 2, 3. And it's a dotted line. I'm just using a highlighter so it's easier for you guys to see. It's not an actual line. It's a boundary. So 1, 2, 3, 4. Where is your horizontal asymptote? Y equals 2. So it's right here. And where are your intercepts? And they both happen to be at 0. Okay, so right here. Now, I don't want to zoom in too much because then we kind of lose the perspective of the graph. Yes, ma'am?
So why is that yellow line there?
That's your horizontal asymptote.
But isn't our...
This is your horizontal asymptote. These are your vertical asymptotes.
I was just kidding. I get it. Okay.
Okay, so look at this graph. I was trying to explain this yesterday to Carlos, and I think it made a little more sense. Do you guys see the 6 regions?
Yeah.
Okay, there's one, we were calling them columns, right, Carlos? There's a column here. There's going to be a part of a graph that exists here. It's either going to be above the yellow line or below the yellow line. It won't be in both spots. There's going to be a part of a graph that exists over here. It's either going to be above the yellow line or below the yellow line. So this is where you get the picking X values and plugging in. If I were you, I talked to somebody this morning, I think it might be the easiest thing to do. I would pick X values that are just on either side of the vertical asymptotes. Right, Aubrey, isn't that what we said this morning? So I'm going to plug in whatever this number is here, whatever this one is here, whatever this one is here, whatever this one is here. It's going to give me an idea of what my graph looks like. Okay, so I'm going to try this first one, the furthest one to the left. So that's 1, 2, 3, 4, -5, right? Do you guys see what I'm talking about? This point right here? I'm going to plug in -5 to my function. I'm going to say x equals -5. So when I plug in -5, what do I get out? What is this, 2x squared? So 2 times -5 squared over -5 minus 16. Yeah, -5 squared minus 16. Okay, so check my math because I'm going 100 miles an hour. What is -5 squared? 25 times 2 is 50. 25 minus 16 is 9. Now here's why I come up with my ish, guys. How many times can 9 go into 50?
5.
Almost 5, right? 5-ish? You guys agree with me? It's 5-ish. It's 4-ish. But what we're doing is we're getting a general idea. Is this point, -5, 5-ish, is it above the yellow line or below the yellow line? It's above. So that means your boomerang is going to exist up here. I don't need it to be the exact point that it goes through. I need to know that you understand it's above the horizontal asymptote versus below.
And how big is going to be a boomerang?
It always will be. Yes, ma'am.
I'm confused on, like, where you get the dots. Like, I know you did choose one on one side and one on the other.
That's just what I did.
But, like, one on one side of what?
The vertical asymptotes.
Oh.
Always. Those vertical asymptotes are super hard boundaries. Your function will never cross them. They could possibly cross the horizontal, but they will not cross the vertical asymptote.
Okay.
So just pick one on either side of it. It's probably your best bet. Yes, ma'am.
If I got like -5-ish instead of 5-ish, would it be below that yellow?
Like for this particular one,
This particular one, yeah. Instead of getting 5, and I got like -5-ish.
what do you mean, yeah?
Like she's saying that it would be, the x would be -5 and the y would also be -5-ish.
Well, yeah, but like that mathematically doesn't happen in this problem.
Like
Okay, yeah, okay, I thought you were saying like, well, I got a different answer. No, yes, correct. Hypothetically speaking, yes. For this one, no, but yes, correct, yes. Christina.
Like, wait,
I'm not laughing at you, I'm laughing.
wait, I don't know ask this, never mind.
Okay, think. Alec, question.
So we don't have to graph like what we found, like we just have to know whether it's like.
It's got to be in the, I need the general area. I need to see all of your intercepts. I need to see your horizontal and vertical asymptotes. The actual picture of the graph needs to be in the general area of where it should be.
So it doesn't have to be exactly like -5, 5-ish.
No, but if you cross the vertical asymptote or the horizontal one when it shouldn't, then that's a problem. Christina,
It's always on the X, like,
you pick an X to find the Y.
okay.
Yes, Jackie.
Let's say when we did -5 and plugged it in,
Mhm.
like, what if it crossed that?
It won't.
Okay.
It never will. It'll never cross the vertical asymptote. So just don't draw it that it does. Yeah.
And you want us to have an X on each side of the vertical asymptote,
Mm-hmm.
and then
I'll show you why in 1 second. Let me finish.
in the middle graph point, you want to have 2.
Yes, and I'll tell you why in a second. Now, look, David asked a great question. I'm going to come to that in a minute. I personally always graph the outsides first. So I'm now going to move to the yellow area to the far right. And what is that point that I picked out there? +5?
Yeah.
Okay, so let's try +5. When I plug in +5, what do I get out? So you're going to use the same function, 2 times 5 squared over 5 squared minus 16. Some of you are like, you get the same thing. That's okay. That's totally okay. If you see that, great. So 25 times 2 is 50, right? Over 25 minus 6 is 9. So again, I get 5-ish. I go +5, 5-ish. Guys, all I need to know, is that above or below that horizontal asymptote? It's above. So this side of the boomerang exists here. Is it always the same every time? No. You could have one that's at top right, one that's bottom left or something. That's why you got to check. Now, the reason why I'm telling you to check 2 points in the middle, when your graph is cut up into 6 chunks like this, your middle section could either be a parabola or a cubic. Parabolas are U's, arrows going in the same direction. Cubics are snaky with arrows going in opposite directions. So that's why I'm saying pick 2 values that are just to the right or left of the vertical asymptotes. Do you see how I picked -3 and +3?
Yeah.
Because you need to see what shape it's going to give you. Yes, sir.
Can you tell from the equation whether it's going to be a
Yes. But not everyone can, so.
It'll just be square.
We're not going to go with, it'll always be, don't do that. If you can tell, you go with it. All right, so I'm going to pick -3 and +3. I picked -3 and +3 because they are just to the insides of my vertical asymptote. So when I plug in -3, I have 2 times -3 squared over, thank you, -3 squared minus 16. So this is 9 times 2 is 18. And then 9 minus 16 is -7. Right, that makes a difference there. I have 18 over -7. So if I look at this point, I don't know exactly where -18/7 is, but I do know it's below or above the x-axis. It's below, right? So it's going to be here-ish, just say. It's definitely below the horizontal asymptote, right? Because it's a negative number. And I know generally it's going to be below the x-axis because it's less than 1. Okay, so let's plug in +3 and see what happens. So I have 2 times 3 squared. 3 squared minus 16. So 18 over -7 again, right? So the reason you check both those points is because what happens on the other side, it's in about the exact same spot. So if you were going to connect those 3 points, what shape is that going to make?
And
It's going to make a parabola. There are some functions that when you plug in one to just the inside of the left vertical asymptote and one to the inside of the right, it goes like this. So if you were to connect them, it would make like that snake-looking thing. So that's why in the middle, you check things that are just inside the vertical asymptotes. It'll tell you the shape of the graph. Yes, sir.
Can you have like the snakes in the sides or only in the middle?
For our purposes, it's only going to be in the middle.
So only in the middle.
Wait, why is the parabola down? Why not like up?
Because you couldn't connect those points and touch them all and make it upward. Yes, ma'am.
So then our final graph would be like these three. And
Everything that is on there is what you guys have to have. You guys need to have, look, you need to have your vertical asymptotes. You need to have your horizontal asymptotes. You need to have any intercepts if there are any. And you need to have your boomerangs. All of that goes into one graph. Yes, sir. If you were to get a hole, it would just be an open circle.
Like, where do I put that open circle? Like, do I-
Wherever the hole is. Like if it's at x equals -2, just put an open circle. Mhm.
But would it be in like the line?
If it is, then it would just go like that. Right?
Yeah, but if it isn't, you just do like a circle. Oh.
Where's Ella?
So the snake in the middle doesn't respect the horizontal asymptote?
Correct.
It just goes through it?
It can, yes. Not all the time. You can sometimes cross horizontal asymptotes. You can never cross the vertical asymptote. All right, questions?